Great, thank you very much, Colin. Right, what I'm going to do is just take about 5 minutes now, just a little introduction to what the H4.0 project is, what 3CEA does, and it's an overview of the project, not the detailed stuff. So Ralf later on will be doing a presentation for about 30 minutes, which is quite detailed about the actual delivery of the project and the technical aspects of it. But I'm just going to give you a quick overview about the project. I'll also be talking briefly about the online training. One of the partners within the project is called Southwest Regional College. They're based up in Northern Ireland in Omagh, and they're responsible for training. And I'll tell you how that fits into the project in a minute. And basically this presentation is about low carbon fabric first approach. So for anybody who's not techie, the first question is, what are you talking about? So we're not just talking about energy efficiency within a building, which is how much energy does it consume as you run it, but we're looking about how much can we cope with energy efficiency by including it in the fabric of the building. So rather than waiting until you have an energy efficient building and then trying to monitor, reduce it, it's how to get the first fabric approach. And Ralf will be going into that in more detail. Then at the end, there'll be about 10 or 15 minutes where we'll take questions, both from Southwest Regional College and for 3CEA. Okay, Ralf, next slide, please. Okay, what we're hoping to convey to you today is what the importance of H4.0 is, what the relevance of the low carbon fabric approach is, how to use low carbon building materials. And this is one of the things which has not yet been grasped by the government in Ireland. It will be very soon because there's a new housing policy coming out. But one of the things to date that we have not really been considering is what's called embedded carbon. So if you're going to build a traditional block house with concrete foundations, you have already built a considerable amount of carbon emissions into the building because of the nature of the materials that you're using. So Ralf will be talking briefly about low carbon construction types. These are construction types that have low embedded carbon, and also about the beneficiaries and what is beneficial for stakeholders. Next slide, please, Ralf. For anybody who's interested, this presentation will be available immediately afterwards online, and I would encourage you to look at the link that we've got up here. What we have already done within the project, and this is not just 3CEA, this is all of the project partners, and I'll explain briefly in a minute who the project partners are, is that we have already prepared Unit 1, which is a construction industry guide to what's called NZEB, which is low embedded carbon construction. We're still working on Unit 2, which is what's called an H4.0 energy platform, and Ralf will be talking briefly about that later on. We have finished Unit 3. So if you go into the link that you can see on the screen now, you'll see that Units 1 and 3 are complete. And at the end of them, there's just a little questionnaire, which is, it does not feed back to us. So we're not trying to measure how intelligent you are. It's just to give you an idea of how much you've actually picked up from looking at the training programs. Okay, Ralf, next slide, please. Just again, overview. For those of you who are used to EU projects, this is a Northwest Europe project. So there are different kinds of programs within the EU, and this one is in Northwest Europe. It's not only a housing project, but it's also to look at how to fill a gap and how to move the country forwards. I'm going to be talking very briefly in a minute about the projects, the actual pilot projects that we've been working on in Ireland, and about, very briefly, about the issues that we've had in delivering those. We're also going to talk about, I've already mentioned low carbon materials and low carbon construction methods. In a nutshell, we can't just continue digging holes in the ground, pouring concrete into it and building concrete block structures on top. That has to change, not only for housing, but for other construction types too. One of the things that we're doing within this project is to look at what's called benchmarking. So this is to try and measure what are you actually doing and what would you expect to get from the outcome of the construction that you have chosen, so that you're going on a route where you've got an identified path with clearly identified targets and deliverables. And overall, what we're trying to do is to develop designs that improve the quality of life. Okay, Ralf, next one, please. You'll be pleased to hear I'm nearly finished. Okay, these are the project partners. So we've got project partners in Belgium, Germany, Netherlands, 3CEA in Ireland. We've got Southwest Regional College in Northern Ireland. We've also got a company called OSL, who are a techie company developing a platform. Hi, Mirth, if I could ask you to turn your microphone off, thank you. We've also got pilot sites, and I'm going to talk very briefly about the pilot sites now. Ralf, next slide, please. Okay, we started out, the intention for 3CEA within this project was to deliver social housing projects in counties Wexford, Carlow and Kilkenny. Unfortunately, Wexford has fallen over. Within the last year, this project has already been running for 2.5 years. There's approximately another 6 months to run with it. And within the last year, Wexford, for various internal and strategic reasons, are required to densify their site. So they had originally identified a site with us where they were going to put in low carbon housing, but they've now, within the last 6 months, have to change that. So they're having to put more units on the same site. So basically they're right back to the drawing board. So Wexford has fallen over. Carlow and Kilkenny have been enthusiastic about cooperating with this project, but it's been difficult because virtually at every decision-making point, they're facing hurdles. Because what we're trying to do within this project is to go beyond what is required on the baseline of requirements within the Irish regulatory system at the moment. So every time we have to make a decision, we're encouraging them and they're interested in doing more than is actually required by regulation. But that is difficult to get funding for from the government. So it's interesting, moving forwards, very often the actors want to move forward, but there are regulatory barriers. So Wexford are not going ahead. Carlow and Kilkenny are, but are slightly behind schedule. So it's unlikely that both Carlow and Kilkenny will be completely finished on site by the end of the project in July, but that's not an issue because both of them have committed to going ahead. So they're committed to using H4.0 construction methods, which as far as we're concerned is what the intention, the objective of the project was. What they're trying to do is to close the demand in social housing units. We're looking for a 60% saving of carbon emissions. And this is not just on the consumption of energy as the building is operational, but also on the embedded carbon, which is part of the structure, part of the materials that you're using. And we're also looking for 25% cost savings in the long term if we can implement this. From the technical, theoretical calculations that we have done, we will achieve these. So it's significant. But what part of the project is to prove this. So the pilot projects have to get up and running and we have to start monitoring them. Okay, Ralf, I think this is where you take over. I think you're hanging in here from the next slide. We'll be taking questions after Ralf's presentation. So I'm now handing you over to Ralf, who's our project officer on this. He's an architect and Ralf has a very strong technical background. Some of the information is fairly techy, but he's trying to deliver this in a way which I think all of you will be able to understand. Ralf, over to you. Thank you.
Thank you very much, Michael. I need to find my slide. So we are working. Also, one target is to develop an benchmark, and we using existing knowledge, and so we orientating on the Passivhaus principles and technique, and use this as a first step. But there are gaps. So especially one target of the benchmark is to reduce the CO2 emission. And CO2 emission are generated by construction and operator building, which are equally important, but the embedded CO2 emission will have an immediate impact, and that will be as well dominant within the next very important decades, where we still are able to change something and mitigate climate change. So this needs to be established in the very first brief setup, and set up as well in the very early design decisions. We need to evaluate at this early design stages, so which impact and influence will have the design at later stages and the end result. Yeah, so but there's a gap in the benchmarking and knowledge, and we try to fill that, or we fill that with our pilot projects, and it's important to look at the low carbon first fabric approach, which where the embodied CO2 emission could be reduced within the early design stage. I think everybody knows about that, and we need to act. We are really urged to act and mitigate climate change effects. And one focus is the current focus was on energy efficiency and reduction of the operational energy. But in the building materials, there's a big potential to save further CO2 emission. So we see in this graph that from 2016, but that at the end, so the operational materials, they're quite the same, more or less. But in the next 10 to 20 years, when it's important to act, the embodied still has a major impact, and that is what we need to reduce. There are fundamental scientific-based research being made, and it became clear that the ratio of embodied operational CO2 emission moved from, you see that here maybe in this graph, the red one is embodied and the operational is the blue one, and that it changed, so from 1/10 to 1:1, because we invested in energy efficiency. But now it's became much more in focus to reduce the CO2, as well as the embodied CO2 emission. I brought up a a graph showing the impact of upfront embodied CO2 emission that is here. So when we have built the building that is at the stage of practical completion, and then we start to hand off and start to living in. So this is the lower part is the embodied part that will rise a little bit by refurbishment and replacement. So and that is as well a scale of 50 years regarding the EU levels. But yeah, at handover we start to gradually increase the operational, also the operational emissions. They will start gradually, but still after 20 years, embodied still have a major impact. And at the moment, we're working on this to reduce the operational energy. That's good. We have at the end some savings, but that's still in 50 years' time. We need to look at what's happening in the next 10 to 20, and there's still the embodied carbon, the major impact, and that is where we want to go. That's our target, and I'm pretty sure we can achieve that. We need to evaluate early design decisions which impact and influence the later design stages and result. By doing that, we need to look where we have the big impacts that are the carbon hotspots. This is capable saving embodied CO2 emission. Hotspots are, for example, cement. Also in the cement production, is used usually a high amount of energy to burn that, and aggregate sourcing as well, and and also fossil-based building materials. As I said, we need to focus on saving CO2 emission. We need to look at the upfront CO2 emission first, and this is in terms of life cycle analysis, and the figures A1 to A5, I show that later on in a graph where you can see that is the sourcing of material and the construction. We call it the cradle to a practical completion. That is lean from this cradle to cradle theory and movement. So, and this we call and pre-ACA, so that you conduct in the pre-design stage. And here we can get circa 80% of the final upfront embodied CO2 emission established. So here we can actually measure them already, what will happen at the end when you conduct a full whole life cycle analysis. So there are lots of ways to reduce embodied CO2 emission. We need to look at those things to the design process and manifest them in the tender documents to make sure that this will be specified and be built. They are using low carbon structures, low carbon products, compact shape, slim slabs, avoid parking structures, flexible space elements, avoid low value elements, choosing long lived products, combine measures. So this is a list from the Irish Green Building Council. There are others from other organizations, but they're quite similar. We looked in our project at the big impacts first and how to mitigate them, and we used substitution as a method. So substitutions of construction types, substitutions of material, that means using low carbon materials instead of fossil based, replace high impact materials. Such as what we were looking at. We thought as well that we need to show that and discuss that and convince our partners to use this methods. So because we need to find out which substitution or combination or measure will achieve how much savings, and then we can decide where the journey is going to. We can choose, for example, choosing the construction type as an initial decision and will shape and influence the result. Yeah. We develop a detailed program for a baseline construction type and 4 improved types. And each of the 4 Irish pilots building designs will be equipped with this baseline and 4 other innovative construction types. And from the design, we compile a quantity of elements. So we have a baseline. It's a TGD 290 and A2. So with a related data and then concrete brick bungalow, also semi-detached bungalow. That is also the case in Carlo. In Wexford, we have an 2-story apartment in timber frame. In the Kilkenny, we have an one as well semi-detached bungalow in ICF, and one detached bungalow, semi-detached bungalow in timber frame, and in Carlo we have an ICF semi-detached bungalow. So and we compare this to the baseline. Also in each design equipped with this different construction types compared to the baseline, and then we get the reduction and also the kilograms CO2 emission per building, and then we can compare that with some benchmarks. Yeah. This is the method, also the standard what we are working with, and here, as I said earlier, there's a product stage A1 to 3, and there's a construction stage 4 to 5, and they all together are the project to practical completion assessment, and that is our pre-LCA. There are different mode. There are different pre-ACL tools. Recently, the Irish Green Building introduced a carbon calculator from one-click LCA. Here you can set up as well a pretty easily baseline and compare with measures that you take on for saving CO2 emissions, also the embodied CO2 emission, and you get really quick some results of savings. So where you see as well really it shows you where the carbon hotspots. Usually that's so external walls and floors. Yeah, that's quite helpful. It's an connected to materials which have an EPD, an environmental product declaration, and that is a way of giving transparent data. So so during the H4.0E project, we use the Ubakus Calculator. It's a German platform, but you can adapt that to the Irish market as well. we use this Ubakus calculator for setting up the details. So you can set up the details and calculate them. So we made these details of all construction types and double check and calculate the required data. So this is first of all, by your calculator, you can calculate humidity and temperature and heat protection, but it has an SA part as well and calculates with relevant EPD data. So 8 to 5, they use this frame, also the practical completion essay. And yeah, with this we set up our tool and this comparement with the different construction types. So this is these are some also an example of our detail setup that is for the external walls, and we have on the left hand side the baseline, and then we have an ICF, and then it's a standard timber frame regarding IS 440, and the same by using low carbon material. And we have an ethics version of an timber frame wall and compare this results. I want to show something also as an example, the Carlo pilot. That's two number of one-story semi-detached bungalows, and so the other pilots I explained already. So we have timber frame and ICF all over our pilots, but they vary in size and scope. Within the Carlo palette, we use ICF, that's insulation concrete framework. That is a ESB insulation prefabricated element that you put on site and erect the wall, and then you pour the CO2 concrete into it. And concrete is a carbon hotspot, and here we use GGBS, which is an recycled byproduct from the steel industry and has the same properties like cement, and that can replace cement in the in any composites, so for screed, for render, for concrete slabs and concrete walls. So, and here's one result. This is on the left hand side we have the standard, and then we also replaced the standard concrete SEM2 with GGBS, and then we nearly achieved 60% savings, but that is an extreme. I'm not sure if but I'm sure we can achieve that, but sometimes it's difficult to convince the people because this has a longer curing time, and but yeah, it needs some days longer to cure, but it's not a big delay, I would say. So then we have an ICF, also the insulation concrete framework, and then we add the GGBS to this. This standard GGBS that has not a high BR standard, it's A3, but when you want to achieve a much better BR standard, you need to increase the insulation, then you have more embodied carbon. So they use the ICF, and we use the GGBS as a substitute, and that are our savings, saving around 47 to 50% of embodied carbon with this construction type. And then we have the standard timber frame. It's higher because here in Ireland they use or the facade is often built out of also added some clinker, and then they have really also that's a high hotspot in this construction type. If you took away the clinker, that will be much lower. And we reduce also use a GGBS clinker, which is on the market, but not very widespread. Then we have this low carbon timber frame, where we use wood fiber and cellulose instead of so in the standard IS 440 they propose to put in pure or phenol-based insulation, which are fossil-based, and they have as well a high impact on embodied carbon. And here we use wood fiber and cellulose, and so this substitution by GGBS for the hotspot is a ground floor slab, and then this is ethics a timber frame with wood fiber and cellulose insulation. We even can save CO2 emission, because the timber material sequesters CO2 emission for its lifetime. And this can be after, if a building is used after 50 years, it can be recycled or thermal used, but as well in a really efficient way. But it will save in the next 10 to 20 years, will help us to mitigate the effects. So the same for the partner. This is just for one unit, and these are 4 units, and there we have a similar picture, also similar savings, and the saving graph is as well really similar. But yeah, that it's that won't be built, but the county council of Wexford, they take on, or they will take on low carbon substitutes, GGBS in the future projects. Besides the Irish pilots built in timber frame and insulation concrete framework, our H4.0E partners in Belgium, Netherlands, and Germany working on different approaches. In America, our Dutch partner using the WikiHouse system. That's point pile foundation, it's a basic steel frame, and OSB elements that are cutted to size on site, and build their elements for the wall, the slab, and roof structures. So most of those 9 pilot houses, they're altogether 18. Also there's one phase 1 is 9, and they are actually already built. The people living in there already. That went out really fast, and they're building at the moment phase 2. The most of them are self-builders, so self-built by their owners, except the foundation and basic steel frame. But it's really an exciting project. They built up a big tent where they prepare the single elements on site and connect them by themselves. That's quite exciting. Another exciting project is in La, or in Southwest Germany, in the Black Forest. Our Austrian partner Thomas Holz is working on a prototype of massive timber of a massive timber solution with a focus on circularity. Thoma Holz 100 consists dual laminated timber, DLT. This is glueless, pure and non-treated solid timber, mainly spruce. And they're using hardwood dowels to bind the single layer with. And they are working on, or they created already, detail sets to easily assemble and disassemble the DLT elements, and these are reusable after 60 years. You can just they plan to they built a prototype house on the site in La, and they will so disassemble it and build a new house out of it after 5 years in Austria. That is the plan for it. So just to show that this is possible. Also that lots of people talking about circularity, they really do it. It's as well a really exciting project. And they can reuse that, and after another period of 60 years, they can upcycle that, downcycle it. Worst case would be after these 2 phases of use, that is, if they don't recycle that, they can use that for generating efficiency energy. In Huldenberg, our Belgian partner use prefabricated timber frame modules, and they use cellulose as insulation, and they have an open plan layout and prefabricated building supply for bathrooms and the kitchen. That's as well also the people living there as well on I think 2 containers are there on the site. Yeah, that are the 3 other pilots. And at the end of the projects, or when they finished, the TODF will conduct a full life cycle analysis of all pilot buildings, and yeah, I'm really looking forward to see this results, and this will be used as well as a benchmark as part of the benchmark for the H4.0E project. Here again some pictures from the self-builder from Thoma Holz and the container in Belgium. So this all shows that zero carbon and -0 carbon standards are practical and feasible. The technology is there, but there are institutional and social barriers on obstacles. Yeah, there's a really good example for circularity and CLT in London, the Morrow Grove Tower. That's a 9-story residential built in CLT. Really exciting as well. And yeah, they had to fight a little bit as well regarding fire, and but they could solve that really easily. Right. So the financial sector has as well really big influence and can support. So climate change is meanwhile accepted within this the financial sector as a financial risk. Therefore, green investment will be preferred and will get cheaper capital, and will get insurances, which is really important for planning them and living in them. And we are sure that an upgrade H4.0E project will be a green investment. Yeah. So the plan was with a Green Deal, EU taxonomy, that those projects are supported as well, to declare them as sustainable activities. And if they get, that was the plan, I don't know, is that still the case? So if the benchmark is at least 20% lower than the minimum requirement, they will be part of this and will get support. But this proposed EU taxonomy and the Green Deal has its issues. So the EU Commission is trying to declare nuclear power and gas as a sustainable energy sources and add these to the list of the eligible activities under the proposed Green Deal EU taxonomy, which is actually a really disaster. I could go on on the negative parts of nuclear, because there are no positives, but one thing is for sure, this will turn the EU taxonomy under the new Green Deal into a greenwashing tool, and we must fear that this could lead to channel even more EU subsidies towards fossil-based nuclear and gas. This is in turn will block renewables and delay necessary and truly climate change mitigation solutions, like our carbon H4.0 homes. So I come to the conclusion. We need to change behavior and change our design strategies and implement pre-ACA into the early design process. So a big impact will be upfront embodied CO2 emission. So a combination of substitution and also mitigation measures is necessary to achieve that. Identifying the upfront embodied carbon as part of a fabric first attitude will be part of the H4.0E benchmark. That is what we're working on, and that's our target, and that we will achieve for sure. So that's from my side. Thank you much. Thank you very much for listening. If you are interested, here some websites and our contact details. So I hand over to Michael and Colin.
Ralf, thank you very much. Colin, do you want to handle, we've already got a couple of questions on the chat line and a comment. Colin, can you handle those?
Yep, sure thing. So the first in from John Smith, it's more of a statement. I expect the insulation and material across all the structure facade types is the same, as this will have a significant effect on embodied carbon. Then also, is there an analysis on the effect of insulation on embodied carbon across the project? So just, I suppose with that first statement, I expect insulation material across all structure facade types is the same, as this will have a significant effect on embodied carbon. Do we agree with that statement, Ralf?
Yeah, we included the insulation material, and of course, insulation material will has an impact, and it depends on the type of on the construction type. So when you have an ICF and concrete building, the cement or the concrete will have a bigger impact, but every it depends on the amount of also where you have the hot spots, but it will have an impact.
And the second part of that then, is there an analysis on the effect of insulation on embodied carbon across the project?
Yes, yeah. As I said, that's insulation is included in this calculation.
Perfect. So the second one then from Shane McGuinness, the 215 inner leaf in concrete block is not typical of anything other than multifamily construction, and 0.18 watt m²K would be a very poor U value by current Irish standards. This builds in two CO2 exaggerations, which will bias the results of the LCA. So again, this statement, would you agree with that, or do you have any input there?
Yeah, and I don't think that's biased. The results you will have you you need to set up an baseline, and you need to compare. And I picked out this types, but I have as well other types, and you see as well what other types have other results. I don't think that's that is biased, because we use this EPD material properties for our LCA, and so and that is a transparent form of presenting this results.
Simon, could I ask you to switch your mic on and respond to that? You obviously think we're kind of cheat here in the life cycle analysis. So do you want to expand on that a little bit?
Yeah, can you hear me?
Yes, we can. Great, thank you.
Yeah, the wall chosen as the baseline is not typical of certainly a single-story house in Ireland. It would be a complete over-design to use a 215 inner leaf. You'd need to be taking concrete loads on a multi-story building to justify the 215 inner leaf. Okay. So using twice as much concrete in the inner leaf, twice as much cement is really the big problem here that you need to use. You're also retaining an air cavity in the cavity rather than fulfilling it, which these days would be untypical in housing, and the U value is therefore too low at 0.18. So there are two biases there. If you compare the U values to the other walls, they're all at 0.12 and 0.11. So the baseline is atypical. It will result in life cycle carbon costs through heat loss, which will be accounted for in the LCA as operational losses. And the embodied additional concrete and additional cement will be counted as part of the upfront carbon cost of the development. So there are two things that would not be typical of Irish construction. So you know, that will affect the results of the LCA.
Great, Simon, thank you very much. Ralf?
But you we show that we want to show mitigation solution. So and to use, for example, GGBS is a mitigation solution, and that is our target. To convince the people to use mitigation solutions and maybe turn to timber frame and use, for example, this ethics system, for example, where you can get much better results and have much better opportunities to reduce your embodied carbon. We don't want to show up here and here this amount we can save. We want to convince people to or the designer, engineers, and people to take on mitigation methods. That is our target. And I think we agree on that.
Yeah, no, we do need to reduce upfront and operational CO2.
Yeah,
there's no question about that. It's just how you go about doing it and how the market should respond.
Yeah,
the concrete industry has yet not woken up to the issue, at least not publicly, and once they do, and I saw on one of your slides there was a possibility of a 65% reduction in the effect of in the emissions of from concrete block. Yeah, so just by changing to GGBS. GGBS is widely used in the concrete block industry already. They just don't claim credit for it. But virtually every block has GGBS in it now.
But only to a very low amount, maybe 30%. But it can be used also for walls, concrete walls. You can use up to 70%, and the same for slabs, I think, as well. And
I think there are production difficulties with concrete blocks at above 50%, and they haven't solved yet. But I'm sure over time they will solve those.
What I know is that they have you need to really adjust your water treatment after pouring. There's so the handling you need a much better trained staff to deal with that.
Yeah, it's difficult. They fall apart.
Yeah.
Yeah.
Simon, thank you very much. Can I ask, we've still got another 10 minutes to go. If anybody else has any questions, there's a little button down on the bottom, reactions. If you put your hand up, and we'll try and get over to you. So
we actually just have another input there from Stephen.
Lovely, thank you, sorry.
Yeah, so Stephen says, this might be talked about in other webinars, but how much does the mechanical and electrical services impact the overall embodied carbon of the building? Would the EC of the M&E equipment be minimal currently when compared to the fabric and structure?
I include a generic value for the building supply. I have it not here, but it's in general around 40 kilogram per square meter CO2.
You know, what would that be in percentage terms of the embodied carbon?
Oh,
is it small?
No,
significant?
It's quite significant. For example, for a when you put on PV monocrystalline, it's having a really high impact. It has circa 2.6 tons per kilowatt peak. That is the upfront of monocrystalline. But it will change dramatically if you use polycrystalline. That's reducing already by 50%. But I don't have the percentage here in front of me.
Stephen, could I ask you to switch your microphone on and ask you, why did you ask the question? Do you think that it's something that's generally forgotten about, that everybody focuses on the fabric but forgets about the M&E bits, which are an intrinsic part of the business of the building?
Yeah, because like at the moment you hear about the fabric and everything, but the M&E equipment, because that's changing from, say, previously it was gas boilers, and now it's, say, maybe heat pumps, and then with PV panels, that should be included and nearly tackled at the same time, so that at least the overall building, say, carbon one, there's within reason, there's no point in saying, grand, you improve the fabric, and like the embedded carbon of that is nothing, but now you have to tackle the issue of the equipment, which with the new constructions, all the equipment mightn't be as easily be accessible. You know, it's more difficult to potentially change the fabric, change the equipment, because if you go, say, if it's a timber frame structure, it'd be typically lower thermal mass, which means it might be more overheating, which means you might need, say, a cooling system. So then the overall embodied carbon of the fabric is down, but the embodied carbon and operation of the equipment is increased.
Yeah.
We include PV, also 2 kilowatt peak per building, also per unit, and we include this generic number for the building supply systems. But you are saying, I don't know if you still see this. I think that's a really good graphic. It's showing what we did in the 19th century, and in the 20s we equipped our buildings like mad with building supply. But we actually could use a proper timber frame. I live by myself in a timber frame building, and they probably use pure in the walls, and it cools down really easily. It's well insulated, but it cools down. This amplitude of the temperature going to the construction is really fast, and you can avoid that by using, for example, wood fiber insulation, which slow down the amplitude and keep your building warm. And if you use the sun as well for so passive, also the passive principles, you use passively the heat of yourself, your building supply systems, and the sun. And then when you see the very right little picture that you reduce your building supply to low carbon, to low tech, so but intelligent low tech and the right material, then we are getting there.
Stephen, thank you very much, because it strikes me that it's something we within this project have not paid enough attention to, because we're using nominal values, but we're using detailed values for all of the fabric structure, but not for the M&E components. So it's something we've got another 6 months to do, and it's something we might build in. Similarly, I'm taking on board what Simon said earlier on about ensuring that the benchmark is accurate. Otherwise, we're measuring against a benchmark which is astronomically high or unreasonably high before we've even started. But you'll probably see, Stephen, there's already a comment from John Smith, and John, thanks for your questions earlier on, saying the Chartered Institute of Building Services Engineers are doing a lot of research on this, and he's referring you to one of their technical manuals. Okay, Colin, are there any other questions?
So just a statement from Niall Crossan, just as he had to log off there. So he just sent his apologies that he had to leave. He says, I can see a lot of crossover with the soon to be published briefing paper from the IGBC National Net Zero Whole Life Carbon Roadmap for the Built Environment. And he passes as congratulations to Ralf and the team, an enlightening discussion, some excellent statistics. Hopefully the presentation will be circulated afterwards, which I can say we will be circulating the slides after the presentation as well.
Great. And I see there's another one there from Simon. Colin, if you want to deal with that.
Yeah, so Simon McGuinness just puts in that the M&D is 20 to 30% of the total. This is not so much initial upfront CO2, but the fact that the energy systems needs to include annual maintenance and complete replacement after 20 or 30 years.
Okay, right. If there are any other questions, could I ask you to put your hand up now? Otherwise, we'll be closing in the next minute or two. So if there's any pressing questions, please put your hand up now. Okay, could I thank you all for attending today? Bits of it were quite techy, but I think that certainly from the feedback that we've got from the questions on the floor, there seems to be quite a high level of technical understanding on the people on this call. This is the first of several seminars that we'll be running. Colin will be in touch. Just before we close, could I say, if anybody wants to input into this project, we would be very interested to hear from you, particularly following on from comments, for instance, from people like Simon. If we're getting things slightly wrong, then the accuracy of the project outputs is going to be flawed. So if you think that you can help us in any way, we're more than welcome, we're more than willing to listen to what you have to say. If anybody wants to take part in the project or wants more details about it, please contact Ralf. Otherwise, I hope to see you again on the next seminar. Could I thank you all very much indeed? Thank you.
Thank you very much.